We're going to start today with our logs, reminding ourselves of some of the things we can find, some of the things we can do on our own without a calculator before we go to graphing on this. Now my attempt here on number 1 is going to be to do the entire problem with no calculator. We'll see how successful I am or am not, okay, in achieving that. So first things first, identify the transformations or the shifts. Now I know we've got this on our notes from yesterday, but we're going to make a quick note up here at the top. When we're doing these, because I know we've seen H and K a lot. Okay, we've seen it, and I mentioned it yesterday, parabolas, square root functions, even some of the growth and decay stuff that we just got done with. So when we're doing these, again, my left and right is going to be what's in the parentheses. And my up and down is going to be what's outside in my K value. So when I'm asked to name the transformations, and again I put shifts there just to remind us, it's just a fancy math word. We've got 2 of them in number 1. So I look and I'm like, okay, so minus is right. And minus outside is going to be down. So those 2 things are going to let me in on some information that I need. You're like, okay, and what basically would that information be, Mr. H? Well, basically that we talked a little bit yesterday about this thing called an asymptote, kind of our fence, that normally is going to be along the y-axis at x equals 0, unless there's a left or a right shift. So since we shifted right 1, my vertical asymptote is going to move with it. Okay, so x equals 1 would be my vertical asymptote. That's going to be the place where my graph gets really close, but it's not going to go through there. So we got our shifts. Okay, our domain and range, actually, we've got to kind of remind ourselves, okay, now how's that work again? Remember, we got a direct connection between our vertical asymptote and our domain. Why? Because domain is x values, and so is my vertical asymptote. So my domain normally is 0 to infinity, but it moved. It moved right 1. So my domain's going to be 1 to infinity. And our range, we said, is going to be the easiest part of all of this, because no matter what goes on shift-wise, my range is never going to change. So, you're like, okay, what have I got here so far? I've got domain and range. I've got my transformations. Sweet. I've even got an asymptote. Now the only part that's left is the graphing. So how does that work? Okay, reminder, one more reminder we're going to put up at the top of the page here. We talked a little bit about the parent graph of logs yesterday, that there's 2 points that we work with. We work with 1, 0 and 10, 1. Now that's assuming I didn't make any shifts. I didn't move anything. But we did move something. We noticed we moved right 1 and down 2. So what does that mean to me? Well, right is moving along the x-axis. So right 1 means I'm going to take my x value and I'm going to add 1 to it. Down 2 has to do with my y values. So I'm going to take my y and I'm going to minus 2. So what's that going to do to my points? Well, bless you, at 1, 0, if I do 1 plus 1, okay, I add 1, that's 2. If I take 0 and I subtract 2, that point will be at negative 2 now. And I'm going to do the same thing with my 10, 1. 10 plus 1 is 11. 1 minus 2 is negative 1. Now, I'll admit, when we go to graph, 2, negative 2. That fits in fine. You're like 11, negative 1. That's, well, we'll kind of guesstimate. We're going to be out here. And then the last thing to graph is just reminding myself it goes right up to that asymptote and keeps going. Okay, and I've got it. Now, I'm going to pop this up on the calculator so we can kind of see that everything's in working order here. And that we did things right. Never hurts to check things. Again, our log button's right next to 7. And really the only thing besides that is making sure I close my parenthesis at the end. So I get that in. We'll take a look at the graph. Okay, again, it looks like it just starts there, but we talked about it does continue to keep going. I pull up my chart. The very first error message before the numbers start is where my vertical asymptote's at. Okay, so that's good. And when I'm going looking for my numbers to plot, I'm looking for the whole numbers. 2, negative 2. Got that. And my next one comes at 11, negative 1. I've got everything I need. So like I said, if you feel more comfort, especially at the beginning, with your calculator kind of doing that, you can, but it really is going to simplify things for you in the long run if we can just kind of work it without it. So we'll do the same thing here on number 3 before we get back into some of the other things that we were doing yesterday. And I'm going to try to zoom in a little more here. So it's a little bit easier to see. All right, so I'm not going to refer to my calculator until a little further in. So first question. All right, we'll get a little more feedback this time, hopefully. What are my 2 shifts in number 3? Which directions? Yes, the video is still running. All right. Left 2. Up 3. So again, the one that I'm focused on for my asymptote is if there's left or right shifts, because they're the ones that move my x's back and forth. So left 2 is going to get my asymptote in here. And that's also going to tell me, like we saw up above, where my domain is going to start. My domain is going to start at negative 2, just like my vertical asymptote. Okay, always make that connection. And then I also can very easily get my range because, well, it frankly doesn't matter what the shift is. It's going to be the same. We're going to go down and we're going to go up forever. So at this point, we've knocked out all the important stuff. I just need my 2 points to make my graph. So, I go back and I go, okay, left 2 has to do with my x's. So with my x, I'm going to be minusing 2. And up 3, okay, goes along with my y values. So for my y values, I'm going to plus 3. And I've got to keep in mind again, let's see if I can squeeze it down here. Oh, there it is. Okay, those are my 2 parent points every time. So basically, I'm just doing these functions to these. So 1 minus 2 is negative 1. 0 plus 3 is 3. And again, you may not every single time have both shifts going on. Like if you get to number 4, you're only going to have a right 1. So maybe I'm not messing with the y at all. Sometimes I will be. 10 minus 2 is 8. 1 plus 3 is 4. Okay. The other thing I've had people ask me before about with this, and we'll get these points plotted, and then I'll show how you could do that, because some of you are more visual, and I understand that. So let's see here. Negative 1, negative 1, 3, 8, and 4. Again, we're going to be hugging the axis. Heading upward. So what I've had people ask me before is, They don't like the whole, I don't like doing all the adding and subtracting stuff. Is there another way? And there is. The other thing you could do, sort of like when we did our square root functions, is I could plot 1, 0 and 10, 1, and then just move the shifts. Left 2, up 3, put a dot. Left 2, up 3, put a dot, and then just connect the dots that way. So if you'd rather do it that way, you absolutely can, okay? They all work. And if I want to double check, make sure I did this right, get in my log, x plus 2 plus 3. Let's see if my picture looks pretty similar. I'm feeling pretty good. I pull my chart. There's my first error message. There's my asymptote. -1, 3, 8, 4. Okay? So I've got ways of double checking, and that's the way I like to use the calculator, is more of my double check than anything else. So that's how the graphing works. Now with the other stuff that we did yesterday, we're going to flip over for that part. Now some of these problems have been done already, and I did this for a reason. One, if somebody wasn't here, I wanted to be able to see. Two, I wanted to let you see different ways of doing this. We talked yesterday about when we do this, we talked about change of base. Now I didn't do change of base on this because I wanted two ways for you to be able to see it. One thing I can do is say, hey, my base to what power equals my of value. And if I can figure that out, either with a calculator or in my head, that's fine. I mean, I could sit and start 6 squared. Nope, not big enough. 6 to the third. Oh, that's it. And get the answer. Or we can do what we did yesterday, where we can take the log of our of value, log of our big, divided by the log of our base, the log of our little. So I can do 216, close your parenthesis, divided by log of 6. I can get the answer that way. So it just depends on how your brain works with that. If you can do mentally this to what power equals that, super. If you can't, we use change of base, and that's not going to change order. Okay? The value of the number order here doesn't change what we do. I still here would do log of 1/9 divided by log of 3. Log of big divided by log of little, just to get some practice. Inverses, again, if you were here yesterday, you grabbed the note sheet to kind of get a reminder of how the process works. If you weren't here yesterday, you definitely want to grab it so you see how this works. So inverses, how does this work? First job, switch x and y. We did that. So once we switch x and y, our job becomes to work on getting y by itself. Okay, but this log of base 3 is here. How do I get rid of that? This is where we busted out the big word yesterday, exponentiate. It was just a fancy way of saying, whatever number this is, I'm going to use that on both sides to turn my equation into exponents. The 3 and the log 3 are inverses, so they go away. This is 3 to the x power. Okay, not 3x. And then when I'm trying to get y by itself, I can add 9 to both sides. Y is by itself. It looks weird, I admit. But that's going to be my answer. So anytime I run into these, just keep locking in on the fact that you want to get that alone, exponentiate with that number. But again, try them out. That's the only way you're going to get to feel more comfortable. It's not going to work any better as you continue to kind of just sit there and throw your hands up because it looks weird. Try it, and if your answers aren't matching up, we'll work with that. 13, okay, rewrite an exponential form. You're like, now how did that work again? Okay, this is where we got into the b and the h and all those other variables. But here's what we basically came down to. This little number down here is going to be the base number of my equation. We always use that word base. So that's the number I'm going to take the exponent to. Speaking of exponents, I find the exponent on the other side of the equals. Base, exponent, and then my last value is going to be my answer or my solution. So when I'm looking at a log, base, exponent, answer. And the nice thing is when we're dealing with numbers with these, I can literally plug this in the calculator and see. 16 squared, 256. It actually mathematically works. And so that's how I like to check and see if I did it right. You know, if I try something like, I don't remember how this works. Was this, let's see, was it 17 to the 1 divided by 289 power, and that equals negative 2? Oh, no, that didn't equal negative 2. And you can play with it a little bit until you find a form that actually mathematically works. So that's kind of nice. The new part today is what if I want to go backwards? What if I want to put it in the log form? Okay, I still see my base, my exponent, and my answer. So when I'm writing it in log, okay, here's what we're going to do. We've got the log of our base. It's going to seem kind of strange, but we'll write it this way for now, just so we've got something to look at. Because that's verbally what we were saying back in 13 through 15. Now what I'm doing is I'm actually going to try and work this out. So I'm like, okay, here's the other thing I always tell people to do, especially when they get to quizzes. People tend to have an easier time with these, and I go, it's kind of like cheating, but it's kind of not. I can take one of my answers from up here and kind of use it to see, okay, how does this work? So if I was doing this one, I'd be like, all right, so log, let's see, the little number was this number. Okay, so there's my base. So the little 5 goes here, okay. Then the exponent went on the equal side. Okay, there's the exponent. That goes on the equal side. And then all I got left is the 25, so the 25 has to go here. Base, exponent, answer. Yeah, that works. And kind of start working them that way. But again, the only way it goes from weird to somewhat normal is by practicing, checking an answer, and then if it's not working, going, okay, what went wrong? And kind of looking. Throwing our hands up doesn't do it. Coming to me, shrugging your shoulders and going, this is weird, I don't get it, with nothing on the paper doesn't get it done. Okay? We got to be willing to kind of fall down a couple of times before we get back up. I even got to think about it sometimes. I'm the teacher. So take some time right now. The key is up front. I will locate it. I see it somewhere. And try some of these out. And if you're having trouble, we can chat. If you weren't here yesterday, get the notes. But have your note sheet out from yesterday, too, to try and help. And we'll continue with this a little bit next time.